Okay, for a given function, f of 2 is the value taken by the function when x is 2. So x is 2, we go up to the curve, project over, we get f of 2. If x is 2.1, we project up to the curve, get the y value, f of 2.1. The rise is f of 2.1 minus f of 2, and that's equal to the change delta y in the actual value of the function. Delta y because, of course, the rise between this point and this point is the change in the y value. Now, recall that what we calculated over here was essentially the value that we would have if we took the given point, which is in all these cases the point where x equals 2, and the point along the tangent line where x equals 2.1. Rather than the point on the curve, we're looking at the point on the tangent line. And that's what happens when we calculate the rise as f prime of x times delta x. That moves from one point of the tangent line to the other. So if we compare these results with these, we're comparing the exact change in the value of x to the value that's approximated by doing f prime of x dx. Now, next problem that we want to look at asks us to find the equation of the tangent line for the given x. Now, to find the tangent line, I gave a three-step procedure just to review this. We've done this earlier in the semester as part of our review. It's essential to be able to find the equation of a line given a point on the line and its slope. Well, to find the tangent line, we will have a point on the line. For example, for the f of x equals x squared function, the tangent line will pass through the point 2, 4, because 2 squared is 4. We have the point 2, 4. If this is the x squared function, of course the x squared graph doesn't look like this, but the 2 and f of 2 would be 2, 4. Now we depict that actually down here. For f of x equals x squared, we have the point 2, 4 on the graph. So in each case, we want to find the coordinates of the point on the graph for x equals 2. Because you're asked to find the tangent line at x equals 2. That's not written here, but it's in the statement of the problem that you've already seen. Okay, then the question is, what's the slope at that point? Now, if we know the coordinates of a point on a tangent line or any other line, and if we know the slope of that tangent line, or whatever the line is, we can find its equation. So then, if we can answer these two questions, we can use what we already know about finding the equation of a line for a given point, excuse me, with a given slope, and find that equation, and that will be the equation of the tangent line. So, for the f of x equals x squared, the point on the curve is 2, 4. We have our tangent line. Our tangent line has a slope. What's the slope of that tangent line? Well, it's f prime of x. What's f prime of x? For f of x equals x squared, it's 2x. Remember, we calculated that over here. F prime of 2 was 2 times 2. F prime of x being equal to 2x, and that's 4. Okay, so the slope of the f of x equals x squared function at the point where x equals 2 is 4. The point corresponding to x equals 2 is 2, 4. So to find the equation of the tangent line, we find the equation of a line through 2, 4 having slope 4. So it's very straightforward. And when we do that, the way I've advocated that you think of the slope of, or the equation of the tangent line is you have the tangent line, you have the point, you have a point xy on the tangent line, and between the known point and the point xy, you have a rise y minus whatever the y coordinate of this point is. In the case of the y equals x squared function, the point's 2, 4, so the rise from the point 2, 4 up to the point xy is y minus 4. The run is x minus 2 because the x coordinate of this point is 2. And now we know that the slope is y minus 4 over x minus 2. The slope from the known point to any old point xy on this line, whatever the x and y coordinates are, the slope from here to here is y minus 4 over x minus 2. And of course, the slope of the tangent line is known. That slope is 4. So that y minus 4 over x minus 2 should equal 4. And we can solve that for y, and we get y equals 4x minus 4. Again, I advocate using this picture and this reasoning to find the equation of a tangent line rather than memorizing a formula that you're likely to forget 10 minutes after you use it. So, one way or the other, I'll accept other ways of doing this, but this is the most reliable way, we find that the tangent line is y equals 4x minus 4. We can use identically the same reasoning to find the tangent line for f of x equals 1 over x at the point where x equals 2. Now, if x equals 2, then 1 over x is going to be 1/2. So the point is going to be 2 1/2 rather than 2 4. And the slope is going to be different. The slope is going to be approximately, well, actually the slope is going to be negative 1/4 if you calculate the derivative of the 1 over x function at the point x equals 2. So you're going to proceed in the same manner. You find the coordinates of the point for each of these functions. You find the slope at that point, which is the slope of the tangent line at that point, and use that to find the equation of the tangent line.